All right, we're going to start doing bar graphs. So bar graphs are an extension of your like frequency distribution. So we do bar graphs actually with quantitative data as well. We just give it a different name when we do that. But a bar graph is a graphical representation of your frequency distribution. It consists of rectangles of equal width with one rectangle for each category. So ideally what it is like the area of all your rectangles should sum to 1 or 100% of your data. The height of the rectangles represents the frequency or relative frequencies. So as you see here, this is that credit card data. So we pretty much got the same picture. It's just what's changing along here. So we got frequency and we got relative frequency. But as you remember, MasterCard, there was 11 MasterCards, which took up about 22%. So we do 0.22. So roughly at about 0.22, we set it there. Usually what we have is this side here is always going to represent frequency or relative frequency. And then our variables are down here. So it sometimes we tilt a little bit, but typically its variables are going to be like, what is your x-axis frequency or relative frequency would be your y-axis. And so we do frequency, we just do whole numbers for frequency, or yeah. And then for relative frequency, we make sure everything is a decimal. So like I said, that 22%, that 0.22. So we make sure like this represents 10%, but we say 0.1, 0.2, 0.3, 0.4, 0.5. So we're going to use that distribution of the aircraft data that we had in example 1 and 2, and then we're going to construct bar charts, bar graphs for it. All right. So here we got our bar chart, or sorry, our frequency distribution. So this is my frequency, this is my relative frequency. Let's make a little box here. So I'm going to put my plot here. So we just need 2 lines. Well, I'm going to change part of this as it goes through this, but what we're going to have here is we have the twin. I'm going to write it like this. So we have the twin, we have the turbo, we have the jet, we have the helicopter. I don't know why I said that weird. And then we have the single, your single engine plane. So if you're doing frequency, I might have a hard time trying to write frequency sideways. We'll see if we can do it. Alrighty. And then this is going to be aircraft. If we do this properly, we would label these axes and make sure that we're saying what we do, what they really are. So this is going to be my type of aircraft. It's going to be the frequency of those aircraft. And if we need to go up to 10 as a frequency, we'll make this 5 here. So we'll do 1, 2, 3, 4, 5, 6, 7, 8, 9. So all we need to do is we just need to make a little bar. So here's my twin, and we'll just make this bar go up to 9. We have the turbo, so that one's only 5. I'm trying to make sure these are even length, but we're doing our best. That's going to go up to 4. Helicopter goes up to 2. And then single goes all the way to 10. And there's my bar chart. If I want to change to relative frequency, I add this in red. I'm going to change a few things so you can see what I changed. We don't really have to change a whole lot. get ready to tally mark here. Only thing it really confuses back, we just have to redo that. All right, so at most we need 33. And this is a little bit. So here we know it's about our 0.3. I'm just going to label it so it kind of fits a little bit. So 0.3 here. We'll have our 0.2 here and my 0.1 here. So we see that turbo, which was just under 0.2, is right here. The jet, where's my jet? It's right there. I think my jet's a little too high. Yeah, because I'm trying to scale it here. Is this supposed to be close to that 10? Probably the way I scaled it before, but this is basically all you do is you just change the scale and then we just put those frequencies in. So I'm just trying to make sure I kind of line them up where they should. So up here, then that 0.4. We also have a Pareto chart. So this is basically, it's a bar chart, except we organize it so we go from largest to smallest bar. There you go. Got ahead a little bit. So sometimes, like I said, it's desirable to kind of show a bar graph. So we have everything in order of frequency. So part of the reason we do this is it makes it just a little easier to look at the data. So if you look at that card data again, we can quickly see it's like, oh yeah, that Visa's first, Master second, you know. Ideally, this is probably better for like when you have more bars to give you an idea what's going on. So we're going to construct one for that data that we did back here. So we made that bar graph. So the only thing it changes from a bar graph to a Pareto chart is just the order of the data. So all we're going to do is to just make sure that we just order the graph in order of the most frequent to the least frequent. So my most frequent was that single engine. So we put that single here. The next most frequent would be the twin. Then the turboprop. And we would have the jet. And then we'd have the helicopter. Once again, we're just going to make our little columns here. So we had one at 10, then at 9, the twin, the turboprop was at 5. So everything should be equal distance. So it's a little hard to do this all by hand, equal distance. This would be your jet, and then this is your helicopter. The reason they're organized in this way, we could quickly look at this data and go, okay, well, clearly twin engine and single engine are the most common. They're almost equal together. We see that fewer pretty close, turbo and jet. Helicopters are probably the least frequent. We can see there's twice as many jets as helicopters. So it just sort of makes the data a little easier to look at sometimes. We can just kind of quickly see what that data is representing. And then once again, if I want to make that relative frequency, we just have to change a few things. I mean, this is going to give me the tools to do it. You can do this with relative frequency. So we know that you read so. I got my relative frequency here. This right here is our 30. And this is my 33. So we put the 30 there. Then we know we should have our 20s about here and my 10 is about here. Just make sure everything's going to be lining up here. One, yeah, it's about the same place. And that's all the difference. So all it is just a bar chart with everything from going from smallest to largest, or largest to smallest. So this is just reading one of Pareto chart quickly, just to kind of go through reading charts because they're just as important as constructing them. So this graph represents the 6 largest islands in the world. So the largest is Greenland, then New Guinea, Borneo, Madagascar, Baffin Island, and Sumatra. So which island is the largest? Well, I can go up, happen to do mud, go, well, the Pareto charts is the first one. Someone says Madagascar and Baffin Island together are larger than New Guinea. Is that correct? So we see here is this one, New Guinea. If we put this on top of this one, yeah, definitely bigger than Madagascar. Oh, Madagascar and Baffin Island, sorry. Bigger than New Guinea. Baffin on top of here. Yep, that's bigger than New Guinea. Approximately, how much larger is Borneo than Madagascar, I'm guessing? Also, if you compare it to Madagascar, oh, pardon me, how large, that's a larger. You can read that correctly. Approximately how large is Borneo? You can see Borneo is right here. That lines up with about, and this is in thousands of square kilometers, so about 750,000 square kilometers. Or another way of writing that, because it's in the thousands, it's going to be 750,000 square kilometers like that. How much larger is New Guinea than Sumatra? So where is New Guinea? Right here. So New Guinea looks like it's maybe about 800. Trying to make a good guess there. Sumatra is here just under that 500. That would be 53, 50, 400, 450. Let's say about 450. Just trying to make some good guesses here. So the difference would be 100 minus about 450. So we would end up with 350. And remember, it's in thousands of kilometers squared. So that's much bigger New Guinea is than Sumatra. So we have our normal bar chart where our variables are on the x-axis. So that's a vertical bar chart. So sometimes what it's called. We had our Pareto chart. This one is going to be our horizontal bars. So basically, this is the same thing as our other bar charts. It's just sometimes when we have like really long names, we just write them horizontally. So the one with that's probably been easier to write like this because we had like a turboprop and a helicopter. It would have been easier to write that as a horizontal bar graph. So this is really the only difference here. So like I said, you just make sure it's just you switch and you put your frequency or relative frequency down here. And then along the side here is where you put that variable that is changing the thing you're measuring. In this case, this one is U.S. employment of U.S. residents. So we got fishing, forestry, farming, manufacturing, managerial, professional, technical, sales, other services. Those different kinds of employment are your variable. And because the names are so long, it was easier just to write them off to the side here than it would be trying to write them down here, as you saw when I was dealing with the jet, or not the, sorry, the aircraft. We're not going to do construction here. We are just going to read it. We are constructed several charts here. We can take a break. So people were asked to vote for the best tasting candy bar, and the results are as follows. So later you're going to see that this is considered probably maybe a bit of a misleading graph. we don't like these 3D bars. Determine if the following is true. Twice as many people thought Kit Kats are the best tasting candy bar than Three Musketeers. So here are my Kit Kats. Here are my Three Musketeers. So this is about where Three Musketeers is. So about twice as many. Yeah, it looks like about twice as many. So about twice as many people thought Kit Kats were better. I'd say that's a yes. You have some questions like that in your homework. So sometimes it's a little subjective. Like I would say, yeah, that's half. Your homework might argue with you a little bit on something like this. To be aware of that. Half as many people thought Crunch bars are better tasting than Snickers. The same thing again. Let's just go line that up a little better. So about here, it really looks like probably like 3 times as many thought Snickers were better. So this is really like 1/3 of people thought Crunch bars were better tasting than Snickers. No, it's about 1/3, not a half. Then we have side by side bar graphs. These are a little different than the other ones. The other ones are basically taking the same data and just making the graph a little different. This is comparing two data sets together. So sometimes we want to compare two bar graphs that have the same categories. So in this case, we had uh, these ones were people's activity on social media. So what you see is you have Facebook, Gmail, Instagram, LinkedIn, Twitter, and what you have is it's two different data sets because some of this data is from 2017 and some from 2018. So this is what I mean. We have two data sets, but they have the same categories. They both have Facebook listed, Gmail, Instagram, LinkedIn, Twitter. Obviously, you can tell this is old data because there's no Twitter anymore. Never mind. The best way to do this is just best way to compare two data bar graphs, two data sets, is to construct both bar graphs on the same axis, putting bars to corresponding categories together. So what you see here is, like I said, we had two different data sets. So everything that's 2017, we wrote first. Then next to it, we want to track to the same categories, and then we put the 2018 data. You get the kind of way to quickly compare some things. So we see, like asking what, how's the popularity going? Well, Facebook seems to be growing a little bit in popularity. So does Gmail, Instagram. LinkedIn and Twitter seem to be about the same. So they haven't really grown very much as far as users going in the last year. So this one is elementary school children are asked about their pet species and gender. I'll try to find a good way to word this. Um, we want to determine if the following is true. So if you could take a minute and think about this, we'll go through it here in a bit. So females are more common among all species. Is that true? So we have the categories that were different. So we had male and female, or with the two data sets, but the categories of people having rabbits, hamsters, cats, and dogs, those stayed the same. So usually it's the one thing that changes is like um, kind of splitting your data into halves here. So we have, like I could just look at just rabbits, just hamsters, just cats, just dogs, but I wanted to look at the gender as well. So then I just split the data into, like up by, split it in half sort of by your female and male. What we see here, females most common. So that doesn't seem to be true here. Rabbits seem to be the same popularity among male and female rabbits seem to be about the same. Uh, Female hamsters, yes, that's true. They're about there's more female hamsters, there's more female cats. And another place where that doesn't work is female dogs are less than males. So females are not the most common among all species. Nope. This next part, there are about as many male hamsters as male dogs. So let me see, hamsters, male hamsters is here, and male dogs, that's here. And if you look, they look to be about roughly the same, if not exactly the same, maybe 14 both in each category. Yes, this one's true. Male cats are the least common pet. Let me see, here are male cats. I think that's no again. So like I said, we do these comparisons because there's certain things that we see here. We see that with rabbits. Gender doesn't seem to make any difference in their popularity. It's about half and half. Hamsters are probably about the same. There's not a big difference between them. For some reason, male dogs seem to be a little bit more popular than female dogs, and female cats are a little more popular than male cats. Like I said, this is a little bit of comparison. Who knows what you do this for? If you were gonna like run a pet store, you want to make sure that maybe you have slightly more male dogs and slightly more female cats, because that's probably going to be better for your market. That's what the market is demanding according to these school children.